Everyone. So someone asked me to record this session for today, and so today's session is on Module 5, Part 3, multiple bonds. In the last session, we spoke about making covalent bonds between atoms, and they all made single line bonds, right? And so today we'll talk about how to make double and triple bonds. Um, Before we start, let's do some review. Let's try drawing the dot structures, the Lewis dot structures for these 5 atoms. So pause the video, draw it, and then come back to it. I'm going to draw right now. For H only has one valence electron, right? And so that'll look like this. Carbon has 4 valence electrons, so carbon structures look like this. Nitrogen has 5, and so I'll draw 1, 2, 3, 4, and the fifth one gets paired up with the first one. Oxygen has 6 valence electrons, and so oxygen looks like this: 1, 2, 3, 4, 5, and 6. Chlorine has 7 valence electrons. So chlorine looks like this: 2, 3, 4, 5, 6, and 7. Okay. And it'll be really important that you guys memorize at least these 5 structures because these are the most commonly used ones for drawing covalent bonds. And so if an exam question pops up, it'll most likely contain these atoms. Another atom could be fluorine. Fluorine looks exactly the same as chlorine with 7 valence. So the same thing, but these are the most common ones used. So I would say I would recommend memorizing these. Next one is going into making double bonds. So in the last session, we saw how we can satisfy octet requirements using like different atoms together. Like carbon can use 4 hydrogens to make CH4 and satisfy the octet. But can carbon and hydrogen and other atoms satisfy the octets using the same kinds of atoms? So can I use 2H molecules to stabilize it? And also, like, H is an exception for octet rule. H only makes like has maximum 2 double valence. Like I think it's called a duplet. And so to satisfy this one, each H has 1 valence electron, and they can share this one and make an H single bond. Or I can draw like this, right? How about oxygen? Oxygen has, oops, I'm gonna draw it like this. Oxygen has 6 valence, and so to satisfy that, what we can do is I'm gonna read out this one to have the double single bond. Sorry, the electrons stick together. I can connect these two atoms together to make a bonding pair, but it still does not complete its octet, right? At this point, it has 1, 2, 3, 4, 5, 6, 7 electrons like in each oxygen atom. And so what oxygen does is end up sharing these guys too. And what oxygen makes is a double bond. And so I'll draw oxygen like this. These are the two lone pairs they both have, and it'll share these electrons together, making an oxygen-oxygen double bond. Okay. Similarly, if I had to draw nitrogen, why don't you guys try it out now? Why don't you try drawing nitrogen, Lewis dot structures, and then complete its octet with these two atoms. So pause the video, draw it on your own, and then come back to it. I'm gonna start drawing now. So if you haven't completed, actually pause the video and try it out. But the structure of nitrogen is like this. And so these guys can connect together, make a bond. It still doesn't complete the octet. Now I have 1, 2, 3, 4, 5, 6 valence electrons in this hydrogen. So in this one too. And to complete this octet, these two can come together, and these two can come together as well. And so what I'll get is nitrogen, nitrogen, my lone pair, and then I'll have 1, 2, 3 of these electrons being shared to complete the octet. So now I have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 valence electrons in each nitrogen, making a nitrogen-nitrogen triple bond. Okay, if that makes sense, let's move on to a little more complex things. Now we're going to make molecules with different atoms and multiple bonds at the same time. Last time we made molecules with different atoms but single bonds. Just now we made molecules with same atoms, multiple bonds. Now we're going to combine them together and make molecules with different atoms and multiple bonds. So the first one we're going to try is carbon dioxide, CO2, and there are basically instructions over here, these 4 points which you can like follow to make the structure. And so we'll do that too. Step one is calculate the valence electrons on the molecule, and if the molecule is charged, then add or remove electrons equal to the charge. And so in this case, we have carbon and we have two oxygen molecules, right? Each carbon atom has 4 valence electrons. Each oxygen atom has 6 valence electrons. But I have two of these, so this becomes 12. And so combined, I have 12 plus 4 is 16. 16 valence electrons in this molecule, right? That's what the first step means. In the event where my molecule was charged, like it has CO2 plus 1, it is not right now, so don't worry about it. But if it was charged, we would have to give or take electrons to create the charge. And so if it's a plus charge, we'll take away the electrons to make it positive charge. If it's a minus charge on the molecule, we give it more electrons to make it negative charge. Plus 1 charge, take 1 electron away. Plus 2 charge, take 2 electrons away. Minus 1 charge, you add an extra electron. Minus 2 charge, you add 2 extra electrons, and so on. But right now, it's just 16 valence electrons, this one. So step 1 is complete. Step 2 says connect the atoms with single bonds. And so what in this case, how you connect them is you won't connect all of them together. You find the central atom. And in this case, carbon will be the central atom because it's a single one, right? So I'm going to write carbon here. And I'm going to draw oxygens around it. And then draw single bonds around them. And so when I drew the single bonds, I actually used some of the valence electrons into making those bonds, right? So point number 3 says, count how many electrons are left and place them as lone pairs. So out of 16, I've placed 1, 2, 3, 4. So 16 minus 4, 12 electrons are still like left over to be placed in the molecule. And so I'm going to place them as lone pairs, that is non-bonding pair of electrons on the atoms. So I'm going to start with the outside atoms and come on the inside. That's more convenient. And so I'm going to do 1, 2, 3, 4, 5, 6, and that makes this octet complete, right? 1, 2, 3, 4, 5, 6, 7, 8. So oxygen octet is complete. I can't put any more electrons on oxygen, so I'm going to move on. I place 6 on there. I'm going to start with 7, 8, 9, 10, 11, 12. And so I've placed all these 12 electrons in the molecule as valence electrons, and so I have no valence electrons left to like adjust anywhere. But one thing is missing is these two oxygens have their octet complete. However, carbon doesn't have a complete octet. And so to complete the octet for the carbon, I'm going to do adjustment. Since covalent bonds are made by sharing electrons, I'm going to make this oxygen atom share an electron over here. Okay. When I put these lone pair electrons in the bond, they will be shared between the carbon and the oxygen. So oxygen still owns them, but now carbon will also own them. And so right now the carbon has 1, 2, 3, 4 electrons. By adding these two, I get 6. And I'll go ahead and add this one also. So what I get is I'll get oxygen with 2 lone pairs left behind, a double bond, carbon, double bond, oxygen with 2 lone pairs. Okay. Another way of doing this, same thing, is I can make this oxygen share this lone pair and one more lone pair. And so what I'll get in that case would be oxygen with just 1 lone pair left behind, a triple bond, carbon, single bond, oxygen, and then these electrons. And so if you see now, this oxygen has an octet, 2 in the lone pair and 6 over here, 2 plus 6 is 8. This oxygen also has an octet, 6 electrons in the lone pairs and 1 in like 2 in the bonding pair, 8. And the carbon also has an octet, 6 over here and 2 over here. So that's a valid way of doing it too. Another valid way of doing this would be by this oxygen sharing the electrons instead. And so that will give me oxygen with 3 lone pairs, single bond carbon, triple bond oxygen, and then a lone pair. So all these 3 structures are valid structures. They are not wrong. They are all correct. And so if you draw any of these, it should be the right answer for the exam. But in reality, what happens is this one is predominantly like present in a more molecules are present in this way than in this way. And so these are called resonance structures. This one is a major resonance structure, while these two are minor resonance structures. And in reality, every molecule is present as all of these kinds at the same time, but it spends more time being like this than being like this. Okay, and so we connected single bonds, we placed lone pairs, and for multiple bonds. So we followed all these steps, and we got these structures, and they're all right structures. Okay, and so I also spoke about resonance structures, which I made sure I did. And so this is all you do to make double bonds. It's that straightforward. You just follow these 4 steps, and then you're done. And so why don't you try solving these 4 molecules? Okay, they are all unique molecules, and they will all present a different challenge to you while doing it. So you should do it on your own. Try it on your own. First one is NH4, and the whole thing has a plus charge. And so this is when you will have to give or take electrons. Second one is NO3, and the whole thing has a minus charge. Next one is carbon monoxide, just CO. I did CO2, this is CO, so it'll be a little different, but you can still make it. And next one is HCN. I pulled this one from the internet for like extra practice. I'll give you a hint for this one. In this case, carbon is a central atom. So try making bonds between nitrogen and carbon and hydrogen and carbon. There is no bond between nitrogen and hydrogen in this case. Okay, so that's the hint I'm giving for that one. You should, I would say, pause the video now, try practicing, have practice drawing all these molecules on your own with the 4 steps, and then come back to the video and see how I solved them and make sure you did the right way. Okay, so pause the video now and do it. I'm going to move on. Hopefully you pause and actually practice it. So for NH4 plus, I have nitrogen and I have 4 H atoms. Nitrogen has, if you remember, 5 valence electrons, and hydrogen has 1, but I have 4 of them, so I have a total of 4 valence coming from there. I also have a plus charge. So a plus charge would mean 1 lost electron, right? And so in total I have 9 minus 1, I have 8 valence electrons to be put in this molecule. And so step 1, I counted them. Step 2 is connect the atom with single bonds. And so I'm going to draw nitrogen, and I'm going to write hydrogen around it. Again, nitrogen is 1, hydrogen is 4. That hints at me that nitrogen is the central atom, not the hydrogen one. And it says connect them with single bonds. So I want to draw single bonds all over them. Done. Step 3 is count how many electrons are left and place them in lone pairs. And so over here I have 1, 2, 3, 4, 5, 6, 7, 8. Each bond is a bonding pair, and so each bond has 2 electrons in it. And I have 4 bonds, I have 8 electrons. And so I have placed all my valence electrons already in the atom. And so that's it. NH4 plus, this is how it is drawn. And I can put a bracket and say plus 1 charge on it as well. Okay, so that's how you draw NH4 plus. Pretty straightforward, right? I counted them. In this case, I didn't need to draw multiple bonds, so that was pretty good. Okay, if you have questions on this, please email me and ask me how to do this, and I'll help you walk through it. But the next one is NO3 minus. Again, I urge you to pause the video and try doing it on your own, and then coming and checking how I solve it. If you don't practice on your own, it's basically useless watching the video. I would recommend and really urge you to practice on your own and then see how I do it. Okay, I'm going to start with counting the number of electrons. I have 1 nitrogen and I have 3 oxygen atoms. Nitrogen has 5 valence electrons. Oxygen has 6, but I have 3 of them, so that gives me 6 threes are 18. And I have 1 minus charge over here, right? So minus charge means an extra electron. And so when I add them together, I get 5 plus 18 is 23 plus 1, 24 electrons to be placed. And so I'm going to start, I finished step 1. I want to start with making single bonds. Oops, not done yet. I want to start with placing nitrogen and then oxygen around it. and making single bonds to them. And by making single bonds, I have already placed 1, 2, 3, 4, 5, 6 electrons. So I'm going to subtract 6 from this. We'll carry over. This is 8, 8, 1. Okay, I have 18 left. So I'm going to go ahead and place these 18 electrons as lone pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yep, there you go. I have placed all the 18 electrons as lone pairs now. That and then done. And now to calculate if I have completed octets. And to do that, let's see. Oxygen here has 6 non-bonding, 2 bonding. It has 8. So oxygen is good. This oxygen also is good. This is also good. Nitrogen though has 1, 2, 3, 4, only 6 electrons. It needs 8. It needs 2 more. So this is not really satisfied yet. And so what we can do now is we can make either of the oxygen atoms share the electrons with nitrogen. So let's start with this one. Let's make this one make a bond over here. I want to be lazy. I'm going to copy the structure again. And so by making the double bond over here, the oxygen shared these 2 electrons. And now nitrogen atom has 8 valence electrons and is satisfied. And so this is how you draw NO3 minus. Okay. There are 2 more ways to do this. We made this oxygen share electrons. We could also make this oxygen share electrons. And in that event, we would have a bond over here, which is a resonance structure for NO3 minus. Or we can make this one share electrons. And in that event, we'll have 1 less electron pair here, and we'll have a bond here. And that's another resonance structure. So NO3 minus has 3 resonance structures, and they're all present simultaneously in the same molecule at the same time. Okay, and so this is done too, and that's how you draw NO3 minus. Cool. Okay, next one is CO, carbon monoxide. And so we did carbon dioxide before, and this is not very different from it. We start by calculating the valence electrons. Carbon has 4, oxygen has 6. I have 1 of each, so that's it. And so these together have 10 valence electrons in them. No charge, so that's pretty easy. And so step 1 is complete. Step 2 is connect the atom with single bonds. There's no central atom in this, so I'm just going to draw a single bond over here. Yep. And by placing the single bond, I took away 2 electrons. And so I have only 8 left to be placed as lone pairs. So I'm going to count how many electrons are left. I did that and then place them as lone pairs. And so I have 8, right? I'm going to do, okay, this one, you could start from the carbon too. It doesn't matter. I'm going to start with the oxygen. I'm going to do 1, 2, 3, 4, 5, 6, 7, 8. You could also do 1, 2, 3, 4, 5, 6, 7, 8. Either one's fine. They're both correctly done. And then it says form multiple bonds to complete octets. And so obviously my octets are not complete here. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So oxygen is fine. Carbon though has only 1, 2, 3, 4 in this case. And so to complete my octet, I'm going to make oxygen share these 2 lone pairs. And so what I get with that is a triple bond. And so if I count now, oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it's satisfied. Carbon has 1, 2, 3, 4, 5, 6, 7 electrons. That's satisfied too. Okay. If you went through this path, that's fine too. Carbon now has 1, 2, 3, 4, 5, 6. Carbon is satisfied. However, oxygen is unsatisfied. And so to finish the octet for oxygen, carbon ends up sharing 2 of his lone pairs. And what you get with that is these lone pairs go away and they form a triple bond. And so the same structure as you got before. Okay, so both were the right paths to follow. You end up getting the same answer. So the correct answer is this, or this. Sweet, we did this step and this step as well. And that's how you draw carbon monoxide. No charge, a triple bond, pretty straightforward. Okay, next one is HCN. And for HCN, oops, we have a hydrogen, we have a carbon and a nitrogen, one of each kind. Hydrogen has one valence, carbon has four valence, and nitrogen has five valence electrons. And combined, I get 10 valence electrons. And I said before, a hint for this one is carbon is central atom, because I know I'm telling you. Um, Nitrogen and then hydrogen go around it. So we counted the valence electrons. We're drawing the single bonds to connect them, make a backbone, and then count how many electrons are left. So I've already placed 1, 2, 3, 4 electrons. I have 10 minus 4, I have 6 left behind. And so I have to place 6 non-bonding electron pairs. That is 3 pairs of electrons on these guys, right? And so I know hydrogen does not have any lone pairs ever. So you can either place them on carbon or nitrogen. I'm going to start with nitrogen. Okay, so I've placed these electrons, and so I have all my valence electrons placed in the molecule. Now what's left is adjusting them to get a complete octet. As we know, hydrogen is an exception. It only has at the most 2 electrons, so this one's satisfied. Carbon has 1, 2, 3, 4, so it's unsatisfied. Nitrogen has 1, 2, 3, 4, 5, 6, 7, 8, so that's satisfied as well. And so to satisfy this carbon, I can make the nitrogen share electrons. It has 4, it needs 4 more. So I'm going to make 2 bonds over here. And by making those 2 bonds, what I get is, oops, forgot to erase one arrow. What I get is this, and these electrons go away. And now if you see, nitrogen has 1, 2, 3, 4, 5, 6, 7, 8, so that's satisfied. And then carbon now has 1, 2, 3, 4, 5, 6, 7, 8, also 8 electrons, and that's satisfied as well. And yep, that's the structure for HCN. It does not have any resonance structures, and so that's the only answer we get. Okay, and so this covers. Let me cross check. I think this covers almost, not almost, like all of the module 3. Okay, it doesn't cover some part of it. This covers almost all of module 5 part 3. There's some part left behind which talks about electronegativity, and I want to talk about that on the next session when I do nomenclature with you, because that's something which goes together. And so we'll talk about that in the next session. But I want to dedicate this whole session to just practicing drawing these complex structures. And I think I'll spend an hour doing this in the session, but it took me 24 minutes to do by myself. But yep, that's all I had for today for this session. Next session would be on Thursday at 5:10 p.m. Oops. At that point, we will go over module 5, the remaining part 3, and part 4. Okay, so see you then. Thank you for watching this video.